this video, what I want to talk about is the idea of impulse. And I think in a subsequent video, we'll do some examples of it. I suspect in this video, I'll just end up talking about the idea. And let me start by framing it from a sort of modeling perspective. If you think about modeling, you can kind of think about a couple of possible approaches for talking about systems. And there are many others that you can think about, but I'll just throw out these two ways of thinking. One way to think is in a continuous way. And when you think continuously, the thing that you say is, okay, the force tells me what the mass times the acceleration is. So I've got a differential equation. And that differential equation allows me to forecast ahead in time and say what the system is going to be doing at each instant in time. So it allows me to give you a sort of continuous picture of how the system is evolving in time. That's really great. Like, it allows you to, for example, do animations, and it allows you to ask questions about what the system is doing at each instant in time. On the other hand, it can often be kind of complicated because it requires that you actually know things about what the force is at every instant in time. Another way to think about modeling is actually to think about a sort of before and after picture. And often when you do modeling that's based on ideas of conservation, you, instead of thinking about a continuous model, you instead think about what's the quantity before some event happens, then the event happens, and what's the quantity after some event happens. So here's a sort of silly example of that. If you imagine having a ball that's bouncing on the ground, let's say it's coming in this way, and you think about trying to model what's actually happening during the time when it's hitting the ground, well, that actually is pretty complicated if you start to think about it, right? You imagine sort of drawing what the keyframes look like, and the ball sort of touches the ground, and then the ball starts to deform in various ways, right? It sort of flattens out into some kind of pancake and begins to push back up off the ground, right? There's a sort of interesting set of keyframes in there that require that you actually have a pretty detailed picture of what the physics of that ball are, right? So that would be an example of what continuous modeling would look like of this ball bouncing. Now, the other option is to say, well, that's fine that you can do that continuous model, but actually, maybe what I'm really interested in is what the ball is doing before it hits the ground and what it's doing after it hits the ground. And instead of trying to view this thing that happens in here as a continuous process, I instead view it as an event, right? So there's some event that takes place, and that event has certain characteristics. So maybe that event is an event that conserves momentum. Maybe it's an event that in which the momentum changes in a particular way. But it's simply a sort of instant. I abstract that to being instantaneous, and I ask what happened before that event and what's happening after that event. Okay. So this is sort of a way of abstracting complicated stuff like the deformation of a ball into sort of saying, well, something happens, and what can I say about what happens without knowing all the details? Okay. So in the context of momentum, impulse is the sort of idea that allows us to do this sort of before and after modeling. So let me give you a sort of another example of that. Let's say you've got whatever it is, a ball, and it's traveling along. And then there's some period of time during which something happens, right? The ball is traveling along, and then it enters this dark zone. And you don't know what's inside the dark zone. You don't know, maybe there are a bunch of kids inside the dark zone that are going to kick the ball. Maybe there's some electric fields that are going to do something to the ball. Something's going to happen to the ball. But eventually, after a little while, the ball exits the dark zone and is moving in a different direction. Right? And the question is, what can you say about what happened inside this dark zone? And what you can say about it is you can say something about what the impulse is. So if we think about this ball that enters the dark zone, before the ball enters the dark zone, it's got some initial momentum. After it leaves the dark zone, it has some final momentum. And so we can say that the momentum has changed during this dark zone. And in particular, there's a change. The change of momentum during the dark zone is given by the final momentum minus the initial momentum, right? All right, well, can we say anything more about this dark zone? Like, what can we say about the forces that were applied to the ball during the dark zone? Well, you can't say a whole lot about the details of those forces, right? You can imagine maybe inside this box there are a bunch of little kids and each of them is kicking the ball a little bit, or maybe there's one really big kid who's kicking the ball hard, or something else is happening. But what you can say is something about what the sort of total effect of the force is. So let's go back to the sort of idea that momentum, that force tells you what the time rate of change of momentum is, or force is a momentum flow. So if we integrate both sides of this equation, what we're actually saying is that the total change in momentum is given by what the integral of the force is, in other words, by what the total flow of momentum into the ball is during that time. So this is sort of adding up all of the momentum flow. And this is asking the question, what's the net change? Okay. This right-hand side, this integral of the force over time, is what's called the impulse. And when you apply an impulse, in other words, when you apply some force to an object over some period of time, that gives you a net change in momentum. So the change in momentum that an object gets over some period of time where there is force applied to it is the impulse that you've applied to it. Okay? The units of impulse, note, are kilograms meters per second, right? It has units of momentum. And where it comes from is this idea that you're basically integrating that force over time.